Hey there, welcome back. Mr. Eicher here. Thanks for joining me again. This is a part 2 of a lesson on inverse functions, chapter 5, section 2. It should be pretty brief, but we want to talk about two things. Number one, how to determine if two functions are inverses, and we use composition of functions. And composition of functions is new to you this year, and it can be a tricky topic, so I want to definitely be thorough in talking about compositional functions. And then number two, just want to do one more time graphically how we can tell visually that two functions are inverses. So let's get started. Inverse functions, two functions, f and g are inverse functions, if and only if both of their compositions are the identity function, which means this, f of x equals x is the identity function. In other words, f of g, right, this is fog notation, f of g, this is not multiplication. It is composition of functions. It's an entirely different operation than multiplication. But f of g of x must equal x, and g of f of x must equal x to be inverses. You could also see this written as f of g of x equals x, and g of f of x, a lot of ofs in there, equals x. You can use either notation, same thing for inverse. So on number 10, it says determine whether each pair of functions are inverse functions, yes or no. The way that we determine that is first we'll determine is h of g of x, does that equal x, question mark. So this is a composition of functions. We start with a function that's closest to x. So we're going to start with g of x. So we're going to take this g of x function, this right here, and we're going to plug that in. Composition is one thing composed into the other. So we're going to take that g of x, we're going to plug it in to the other function where the x is. So it's going to look like this. Here's our g of x function, 1/5 x plus 7, right? That's what I have circled right there. And we're going to plug that in to this function, the h function. So that means I'm plugging it in where the x is. So we have a 5, we have a -7. That's what this function's telling us to do. And now I'm going to simplify that. So the question is, does this, what I've written, does it equal x, question mark? So let's simplify it. We have 5 times 1/5. So these are going to divide out. So we have x plus 7 minus 7. And then we have x, and x equals x. So that's a really good sign. The last thing that we do is the other composition. So on this first one, we did h of g. On this next one, we're going to do g of h. So now the question is, does this equal x? Question mark. So again, looking at composition of functions, let me erase this a little bit. So now we're going to take this function. Again, we start closest to the x. So we're going to take this function first. We're going to plug that into the other function. So here's my h of x function, and I'm going to plug that into this function, which is 1/5 times that plus 7. And does that equal x is what we're wondering. So let's simplify that a little bit. The order of operations here we have to be careful about. We should work inside the parentheses, so we should do this -7 plus 7 first. So it would be 5x. The 1/5 still out there. Does that equal x? And 1/5 of 5 is 1, so x equals x. So we would say yes, g and h are inverses since both compositions equal x. So basically the thought is, if they're inverses, they should be able to undo, their operations should be able to undo each other, and then you're just left with x, what you started with. So let's do the same thing on number 11. So we'll start with, it doesn't particularly matter, we'll just do f of g of x. Does that equal x? Does that equal x? So again, we're going to start with the function closest to x, so g is closest to that parenthesis x part right there. So we start with the g function, the g function right here. And we're going to take that function, we're going to plug it in here. So that would be a 6 times x plus 4, where this x is now 16x minus 4. And the question is, does this equal x? So let's see, if we distribute the 6, we would get 1x minus 24 plus 4. Does that equal x? And no, definitely not. We get x minus 20 equals x. Those are not equal. So at that point, we don't have to do the other composition. If one of them doesn't work, then it doesn't really matter to do the other one. We can say no, f and g are not inverses, since the composition f of g of x does not equal the identity x. Now, if you wanted to do the other way, just to really verify for yourself, you would do the g of f of x. So just to do that quickly for you, you would take the f of x function, you'd plug that into the other function and see if this equals x. And this would be a x plus 6, or 4/6 minus 4. That definitely does not equal x. So neither one of them works. That was the first part of the lesson, determining using composition of functions. Composition of functions, again, is kind of new for you and also a pretty important mathematical concept. So I wanted to review that with you, and it's kind of convenient that we use it to determine inverses. The last part of the lesson is a graphical part. When the inverse of a function is also a function, the original function is called a one-to-one function, and it passes the horizontal line test. And graphically, like we mentioned in the previous video, inverses are reflections over the y equals x line. And I've given the y equals x line as a dashed line in each graph below. And I'd like you to sketch the graph of the inverse of the bold line shown, and then which inverse is not a function. So let's start with number 12. What I like to do is find some representative points, some points I can tell exactly where they are. So here's some points on this line that I can tell exactly where they are. And remember, for an inverse, we're going to take that ordered pair, so this 1, 3, and we're going to swap the x and y. So that would be 3, 1. 0, 0 is swapped to be 0, 0 again, and -1, -3 is swapped to be -3, -1. So this line is our inverse, and notice that it's a reflection over the dashed y equals x line. And I'll do it in red so you can see it a little better. But those are inverses. This point is a reflection, reflect over the line, and you get that other point. Number 13, again, I'd find some representative points. We have 0, 0, 1, 1, and 2, 4. And then we have some points on this other side. Oh, by the way, on the first one, I'd asked which function of these inverses this inverse is a function. That's a function. If you have the black line, you can see it passes the vertical line test, right? Any vertical line will only hit one place in that function. But you can tell originally from the original function, if the horizontal line test is passed, which it is for this original line, then its inverse is going to be a function. So as we look at this one, we can tell at the beginning that the inverse will not be a function. That's because, note, the original doesn't pass the horizontal line test. Meaning if you draw a horizontal line, you hit the graph in 2 points. But if you don't believe me, you can always graph and see for yourself. So let's do that. I already have some representative points on this. So 1, 1 is still going to be 1, 1. 0, 0 is still 0, 0. -1, 1 is now 1, -1. So down here. 2, 4 is now 4, 2, and negative 2, 4 is 4, negative 2. So here's our inverse function. And notice this inverse that I've drawn right there, this is not a function. If you draw a vertical line, then there are 2 values in the range for 1 value in the domain. So it is not a function. But the graph shown is the inverse of the parabola. So this is the inverse. And we know parabolas are y equals x squared. The graph that we have here is actually y equals plus or minus square root of x. And that's what you'll be talking about in the next lesson. But for our last one, the last one we have is a try this. So you'll get to determine which graph is a graph of the graph shown here, what graph of the inverse is shown here. Thanks for watching this video. If you made it that far, give me a thumbs up. I appreciate it. See you in class.